Okay, welcome back to what is part 5 in this series. We're looking at conditional code and how you plan for the unexpected. So what you might want to think of is if you hit a traffic jam, you may need to change your route. In code, if you plan for different conditions, using an if statement. So if the light is green, bike walks forward across the street, which can be written if light is green, using if and add your condition, and that condition can then either be true or false. So in this instance, if light is green, we would then add move forward, and then that condition is true, so bike walks forward. So if light is green, move forward, else wait. So if we want to do something under a green light, we can, and then if anything else is happening, well, then we just wait. So let's get into it. Let's have a look, and we'll check it out now. Okay, so using an if statement, we need to toggle only the closed switches. So we have 3 switches here, and they could be in any sort of order. So we can't just write a static code. We need something that's going to be adaptable. Now, first thing we want to look at is how many times do we need to run this code? Well, he's going to start here, so that'll be 1, 2, 3, 4, 5. That'll be 5 times we need to run the code. So we need to move to the first switch. So let's just go with move forward, because we know we need to move forward once. We need to add if, and we can put is on close switch, and we toggle the switch, and then we move forward, else move forward. Does that work? Well, let's try it. Let's run it and see what happens. So we're going to get him to move forward. He moved. He's not on the switch, so he does move forward again, and there we go. So we need to move forward once. We need to then repeat that 1, 2, 3, 4 times for this code. So let's say for I in 1.4. Let's just pop this in a for loop and run that code, and let's see what happens this time. He's going to move forward, then 1, he's on the close switch, 2, 3, he bumped into the edge. Do we need to run it 4 times, or do we need to run it 3? See what happens if we change it to 3. So move forward, then 1, 2, toggle the switch, and he didn't do anything. And this is why we need to run it 4 times. We need to complete this final code 1 more time, which is why we set it to 4 in the beginning. So even though he tried to walk off the edge because he was on an open switch, we still needed to complete that code, otherwise he wouldn't have checked for that final square and would have left it as it is now. So again, if we run that 1 more time, and there we go, toggle the switch, move forward, and then there's nothing else there, so we're done. There we go, well done. If you're not sure, as always, check, see what happened in the code, play around with it, see if you can come up with a different solution. But that's just a nice, basic, simple, straightforward way of getting to solve this problem. And then we'll move on to the next one. Okay, so using if and else if statements now. So to toggle a switch or collect a gem, point here is if we are on a closed switch, we toggle it open. Otherwise, if we are on a gem, we collect the gem. So there are two potential squares, so we need to check both of those. For I in 1.2 move forward, and then if we are is on close switch, hold the switch, else if is on gem, collect gem. And that should work. So let's run it and see. Yeah, so close switch, toggle set, move sword. Easy. Let's try it again, just to see if any gems appear, just to make sure. And there we go, we collected our gems as well. Awesome work, guys, well done. Okay, so this time we want to use conditional code inside a loop, which we've been doing, but we're going to just up that scale a little bit. So in this puzzle, there are 12 tiles that contain a gem, a switch, or a portal. If there's a gem, we collect it. If there's a closed switch, we open it. And if there's a portal, we move forward. So this is our objective. What we need to do is write a long series of if statements that we combine with the loops, and then we write that out. Now there are 12 tiles, so we know that we need to repeat it 12 times. And we might potentially need to do an if-else block as well. So first things first, we need to move forward. We know we need to move forward. And then we need to check if we're either on a gem or a close switch. So I'm going to go with the gem first. So if is on gem, collect gem, else if is on close switch, toggle switch, and that should work for us. Let's just break that down. So we're going to run this code 12 times. The first thing we're going to do is move forward. So we're going to move forward, and Bite is going to end up here. If he's on a gem, he'll collect the gem. Otherwise, if it's a close switch, he'll toggle the switch. Then he'll move forward again, and so on and so forth. So let's run that code and see what happens. Okay, first is an open switch, so we move forward, we toggle, move forward, toggle, move forward and collect, move forward, toggle, move forward and through the portal, move forward, collect, move forward, collect, move forward, collect. One more toggle. Does he collect the last gem? Yes, he does. Congratulations! So we completed all of those 12 tiles with this tiny little bit of code. This tiny amount of code. Excellent work. Well done. Let's move on to the next one. Okay, so we need to use an if statement to trigger a sequence of commands if your character is on a gem. So a condition like on gem is either going to be true or false. They either will or won't be on a gem. Simple as that. So this is what we call a Boolean value. Often these are used with conditional code to tell a program when to run certain blocks of code. So in the if statement, we need to use the Boolean condition is on gem and add commands to run if the condition is true. So I've deleted the code, so we can start from scratch, and we may need to tweak the number of times our for loop runs. So first thing we want to do is look at the pattern. So we have to climb up here. Okay, so if we're on a gem, we need to collect the gem, and that would be here. So we need to move forward first. So what we can say is, if we're on a gem, collect the gem, else move forward. And we could just repeat that for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times, potentially. We'll check it in a sec. So let's do the basics. So 4i in 1, 2, 2, 13. If is on gem, collect gem, else move forward. That looks like it might work. I mean, it's not going to complete the puzzle, that's a fact. That's guaranteed. But I just want to show you the first part on where we need to add some extra steps in. So let's run that to start. He's collected the first gem. Now he's gone straight forward and he's going to just keep trying to walk off the edge, which obviously isn't going to work, so we're going to stop it there. So what we've noticed is we need to collect the gem, and then we need to turn up here somehow. So we need to turn left up the step once he's collected the gem. Now, does that pattern repeat? Well, yes, it does. If you see, every gem is immediately met by stairs to the left. So we need to turn left at every time. So all we need to do is add a turn left command after our collect gem. And now if we run it, it should, in theory, complete. You collect the gem, turn left, and we waddle on, keep going, collect another gem, turn left, another gem, turn left, and he stopped short. We are a little bit short, so let's just up that to 15 times. So those settings are 14, 15, no, it'll be 16. There you go, it's just my bad counting for you. So let's check back again, and off he goes, and this should complete now. And there we go. We have just used a for loop with some booleans to complete a nice puzzle. Well done. So let's move on to the next page, unless you need to revisit anything. So pause the video, rewind, go back and watch it again, whatever you need to do, and yeah, catch up with you on the next page. Okay, so in this one, we need to use a function, a loop, and a condition to collect gems or activate switches. So in the puzzle, every other forward movement might lead to a gem, a switch, or nothing. So when we run the puzzle, the wireframes will show the locations where items might appear. To solve the puzzle, we could write lots of if statements, but there's a better way. So we break the puzzle into its basic patterns, with 3 major patterns, each with 2 possibilities. Either gems or switch. So we use an if statement to define the collect or toggle function to check the contents of a tile. And then below your function, we call collect or toggle and other commands to solve the puzzle. So let's break that down. Define the collect or toggle function. So that would be something nice and simple, like if is on a closed switch, toggle switch, else if is on gem, collect gem. So there you go, nice and simple. Collect or toggle. If it is on a closed switch, we toggle the switch. Else, if it's on a gem, we collect the gem. Nice and easy. So now we need to do some other stuff. Let's break this down a sec. So let's look at the puzzle. We have byte here. So here's a row, and here's to turn left, and here's another row, and then he will turn right, and then he has another row. So effectively, if we can write a repeating pattern for this row, we could just reuse that code multiple times over, and then all we have to do is worry with the navigation. So I am going to create a new function called solve row, and in this function we will put let's have a look. For I in 1, 2, 3, 4. 1, 2, 3, 4. Yeah, 4. Let's go 4. We're going to move forward. So that's the first thing. We need to move forward. And then we will call the collect or toggle function. And that should work. So if we just call solve row just to try it out. So that should repeat 4 times. 1, 2, collect, 3, 4, toggle. There we go. So we know that works for the row. So we've solved the row. Okay. We also need to turn left. Let's put left row, because it's not just turning left, we also need to do some movement. So we need to do a function for left row. So we're going to turn left, and then we need to move forward 1, 2. So we're going to do for I 1, 2, 2. Move forward. So but we'll turn left. Move forward once, twice, and then we turn left again. So we're just going to put another turn left. Okay. So if we call our 2 functions solve row then left row, let's just see what happens. So we know the first part is going to solve fine. What we're looking for this time is for byte to move down these stairs and then turn around to be facing this direction, because then we can call another solve row. Exactly like that. That's perfect. That's exactly what happened. Okay, so if we've got a solve row or left row, then we need another solve row, because the pattern is just a repetition of where we started. He's going to move forward and then either collect or toggle 1, 2, 3, 4 times. So that's absolutely perfect. So when we get down here, we can see byte is going to need to turn right this time, so we can't call our left row. So we are going to need another function. I'm going to call this one right row, and in this he's going to turn right. So he will face this direction, and then he's going to need to move forward and finally turn right again, because he doesn't need to go on any steps this time. He'll just turn and face up there. Okay, so we've got a solve row for the first row, left row to take him onto the left hand row, and then another solve row. Then we need a right row function to navigate this corner, and then we need one more solve row to take byte from here up. Let's see if that works. Looking good so far. There you go. If he turns right again, and then calls the last solve row, moves on down, gets to the end, toggles that switch. Beautiful. Look at that. That is beautiful. Okay, there was a lot in that one. There was some, you know, slightly more complicated stuff there. So, take time to absorb what you've learned. Pause the video, go back over it, check your code, whatever you need to do. Come up with some different ways of trying to solve it if you want, you know, whatever you want to do. And then when you're ready, hit that next page and let's move on. Okay, welcome to Boxed In. So with this one, our character is surrounded by a grid of possible gem or switch locations. We need to figure out how to move to the right locations to collect gems and toggle switches open. We will need functions, loops, and conditions. So I really liked the collect or toggle function. I think that worked well from the last one. So we are going to start by creating a new function. So if is on gem, collect gem, else if is on close switch, toggle switch. Okay. So we've got our collect or toggle. That will cover us for all of the squares. Okay, so now we need to look at the pattern. So this is a 3x3 grid. So realistically we need to, because we're not going to get anything on this middle start point. So I think if we move forward and we can call our collect or toggle and turn right, move forward, and then turn right again, so we're on this grid, then that will give us the ability to sort of go forward here, then we can do all this row, and all this row. So we would have covered there, and there. Yeah, so we're effectively going to go forward, turn right, and then do like a U shape to cover all the tiles. So I'm going to call the first one start row, and in start row we are going to just move forward to this tile, and then we're going to run a collect or toggle function just to see what's there, and then we are going to turn right, move forward, and turn right. If we just call start row and just run that, that should position us to be facing down this direction. There we go. Perfect. Absolutely perfect. Okay, so now we need to just start completing these rows. So we're going to come down, and we need to turn right when we get to the end. So 1, 2. Okay, so if we want to, okay, yeah, fine. So we're going to call the next one complete row. And in complete row, we are going to do a for loop. 2, I believe. So we're going to run collect or toggle. And then move forward. And then turn right. And that should get us to check both of these, move forward and then turn right. So let's check that. So we're going to walk forward with our start row function, collect that gem, turn right, move forward, turn right. Then we should collect the toggle, move forward, collect our toggle, move forward, turn right. There we go. Okay. Okay, so we just need to repeat this now, so. Okay, if we run start row as our start of our code and then just write a for loop, we should just be able to call the complete row function and run that code. So it should run 4 times. So start row, collect the toggle, turn right, move forward, turn right. This is the start of our complete row. So 1, it's 1 cycle. This is the 2nd cycle. Collect our gem. 3rd cycle. 4th cycle. We run it too many times. We didn't need to run it that many. We only need to run it 3. Let's try that again. Just run it the correct amount of times. So start row. No, we didn't need to run another 4 because of that one there. There you go. But what we could do is change our start row to remove the collect toggle and just get him in the right position. Let's run that one more time. I just don't like wasted code. There you go. Back to the start point. Excellent. That is perfect. There we go. Well done. So again, like always guys, check the code out, see what you think. If you're happy, move on. Let's hit that next page and get to the last part. Okay, so this is the last one. Now, if we just look at this puzzle, there's a lot going on. Okay, we need to walk forward, pick up the gem, we need to turn right, turn left, pick up this gem, we need to turn it back around, come back, come forward, toggle switch, pick up gem, come back. We need to do a lot. So one of the first things we can see is we need something that's going to turn us around. So before we even do anything, I'm going to start with a turnaround function, because I know we are going to need to turn around several times. So it's going to do a turnaround function. There, we've got that. We've got a turnaround function. Now, if we look, these are steps, and all of the steps are on the right. So I want us to kind of have some sort of descend the steps type function. So I want us to have a function that we can call to repeat on these steps. So we need something that's going to turn us right to face them, and then move forward to get down the steps. So next up is a function called descend steps, and that is going to consist of turning right and then moving forward. So if you think we are going to be here, I'm going to turn right to face here, then move forward 1, 2, 3. We should end up sort of here. And then we might as well write the gem collection as part of descending the steps, because that's why he's going down there. So if we get him to turn left, move forward, collect the gem, turn around. Yeah, I like that. Okay, so move forward, there we go. And then we are going to turn left, move forward, collect the gem, and then turn around. There. Okay, so what I'm going to do is just run a basic move forward and then descend steps, just so we can test that out. So we're going to ignore this a second. Okay, there you go. That worked really, really nicely. Okay, that was nice. That was nice. So we need to get back up the steps. We need to write an ascend function. So we're just going to call that, we need to move forward. Right goes here, then we turn right, and then move forward 3 times, and then turn right to be facing this direction. So for 1, 2, 3, move forward, and then turn right. So if we run that again, move forward, descend steps, just so we can watch to make sure Byte does actually come back up the steps properly. So we know all this works. Just going to turn around to be sure to move forward, turn right, and move forward back up the steps. And then turn right to face the correct direction. Excellent, there you go. So we've got that part absolutely spot on. Okay, so what we can see here is a pattern. Every time there's a gem, it needs to turn right. And every time there's a switch, it needs to turn left. If it's a closed switch, that switch is open. But if it's a closed switch, he needs to turn left. So can you see that? Gem needs to turn right, gem needs to turn right, close switch left, close switch left. So I think we can start combining some functions. And what I want to do is create a larger function called solve right. So if I call solve right, and in solve right, it's going to be basically a compilation of everything we've just done. So we're going to have collect gem, send steps, and ascend steps. So effectively, we're going to collect this gem, descend the steps, and go back up the steps. And that's going to solve the entire right. So function solve right. Func solve right will solve that entire right side for us, which means we can have a func solve left. And in that we need to essentially toggle the toggle the switch, turn left, move forward, collect gem, turn around, move back, turn left to face the other direction, which is what we're going to do. So we're going to toggle the switch, turn left, move forward, collect the gem, turn around, move forward, and turn left. That will solve our left. And the way we're going to put this together is in a for loop. So for I in 1 5 times, 1 2 3 yeah, come on, bye. I think 5 times. So we're going to move forward to get us started, and then once we move forward, if we're on a gem, we're going to solve right, else if is on close switch, solve left. And that should work. Let's give it a go. Let's see. We've got our first move forward. He's on a gem. He's going to collect that gem using the solve right function. Walk down those stairs. Looking good so far. Should turn around, go right back up to the top. So that is 1 cycle. 2 cycles. Now he's going to solve left. He's going to turn back around. 3rd cycle. 4th cycle. He's going to solve right. Now he's going to turn back around and ascend those steps. And that's our 4th cycle complete. And our 5th and final, he's going to solve left after toggling that switch. Ta-da! Look at that, nice and easy. So look, coming up in the next episode, I appreciate this was a really long one. We're going to look at logical operators and not, equal to, all that kind of stuff. So keep an eye out for that. That'll be a meaty one, might be split into multiple parts just to really give you time to get your head around it. But thank you for staying with me for this one. I appreciate it's been quite lengthy. There's been some detailed stuff in there, especially if you're new. All the pros who've accidentally stumbled across this video are like, oh, this is baby stuff. But, you know, when you're new, it's difficult. And something like this really, really helps. So good luck, guys. Well done. Keep practicing. And, you know, check out my Twitter. Links in the channel description and bio. So check out the Twitter handle. Send me any tweets, any questions or whatever you've got. And I'll catch you in the next episode. Thanks for your time.